Hello everyone. Today I'm going to show you how to create a medical gas outlet in Revit. A couple of weeks ago I showed you how to create a medical gas zone valve box for 3 gases. Then I showed you how to tweak or modify that medical gas zone valve box so you could add or remove a medical gas. Then I showed you how to create a medical gas alarm panel. And now today we're going to close it up with creating a medical gas outlet. So these are outlets that can be used for any type of medical gas, oxygen, nitrogen, medical air, medical vacuum, waste and aesthetic gas disposal. And these that you see here are intended for wall mounting. So, head walls or any other type of walls, but they're very flexible because they're not hosted. So they're free to be placed wherever you want them. So you can place them even on a boom if you want to. Okay? See you in Revit. Hi everyone, this is Alex with BIMitUp, where we help you with professional training and coaching in mechanical, electrical, plumbing, fire protection systems, and Autodesk platforms like Revit and AutoCAD MEP. Let's get started. Okay, so this is what we want to create. It's a medical gas outlet by Amico. Is a DISS type. That's this type of connector right here. And from the cut sheet, we can see that it has a type K 1/2 inch outside diameter pipe stub, which is this little guy here. And then if we scroll down a little bit, we can see all our sizes. We can see the exterior dimensions of the plate, 5.5 inch by 5 7/8. And then, we have the thickness right here. So we have the wall. We'll probably create a few working planes here. Maybe the front face of the wall and then the front face of the plate right here. Then maybe an extrusion here for this little DISS nipple. And then an extrusion towards the back of the wall. And obviously one plane for the connector. So let's just play by ear. And if I need any other dimensions, I can get it from the CAD file, which I already downloaded. And it's this one right here. So, I can measure real size anything that I need from here. But before anyone says anything silly, I am very aware that Amico has this very nice family and it looks very pretty. But I just don't like the way it behaves. And I want to create one on my own that I like how it behaves. That's all. Okay? And just for fun. And also to help whoever needs to create one in the future. Okay? So let's close this up and let's get started. So just like we have done a bunch of times in the past, I'm going to create a new family. So I come here to new. And then as a template, I'm going to select a plumbing fixture. And I don't want a wall-based plumbing fixture, even though it's a little bit counterintuitive because it is a wall-based thing. Wall-based families are good for architects, not for MEP consultants. They're really painful to work with. So I'm just going to go with a standard plumbing fixture. I'm going to hit open. So I want it to fall from the top, right? I want the top of my part to be this. So I'm going to create a couple of planes. So right click, create similar, and I'm going to pick lines and I'm going to give it 1/2 inch. And then I'm going to do the one in the front. And then this plane right here, remember it's always a good idea to name your planes. So this one's going to be the back of wall. This one I can actually rename as front of wall. And then this last one I can rename as front of plate. Now I have to define some dimensions. So I'll just come here. And you always want from your strong reference to your weak reference. So I'm going to keep the front of the wall be my strong reference. Okay, so from here to here, I'm going to change the scale here so I can work a little bit better. And then for this dimension, I'm going to create a parameter, right? So I come here, create parameter, and that's going to be the plate thickness. That's going to be a family parameter. Type parameter is okay. I'm going to keep this under dimensions. That's fine. Okay. And then that faceplate thickness is about 3/8 of an inch. So that's what I'm going to use. I come here, and then to the plate thickness, I assign 3/8 of an inch. Very good. Now we do another dimension from our strong reference to the weak reference, and this we're going to call the wall thickness. So create new parameter, wall thickness, type is okay, dimension is okay, family parameter is okay. And now, for now we can keep it as 1/2 inch, but now it's very nice because we can flex, if we wanted to, between 3/8 of an inch and 1 inch, which is what the cut sheet says. So let's keep going. Now we have to extrude to the back 2 inches to the back of this little drum here. So let's do that. So we click here, create similar, pick planes. We know that that's 2 inches of offset. Then notice that if I approach from the top, it puts it on the top. If I approach from the bottom, it places it on the bottom. So we want it at the top, so we approach from the top. And we're gonna call this back of drum. And these are just names that I'm making up. You can call them Nancy or Julio or whatever you want. So back of drum. That's great. And now finally I'm gonna have the reference plane where I'm gonna have my connector, which is this guy right here. So create similar, and I'm gonna make this 1.5 inches of offset. I'm gonna pick a line. Yeah, that seems about right. So this is gonna be my connector plane. So connector. And now we need a couple of planes in this direction to limit our width, right? So create similar, and let's see. That's gonna be 5 inches total. So I'm just gonna give 2 inches for now, and then I'm gonna associate the parameter and have that parameter be 5 inches to make sure it's flexing fine. So click here, create similar, pick planes, 2 inches to this side, and then 2 inches to this side. I'm gonna rename this guy as right plane, and then this guy as left plane. Actually, let's call it exterior right, and this one exterior left, because I'm gonna have an interior plate, right? So that's pretty good. And now let's define our width. So I'm gonna create this dimension from here to here, and I'm gonna call this the width. Actually, I'm gonna call this exterior width, right? Type is good, dimension is good. Okay, and now I'm gonna give it the right value, which was 5 inches. And I actually like doing this because then I see how things flex in real time. Oh, I made a mistake here, so I'm gonna do undo. What did I miss? My equal constraint. So that's important. So let's do that from here to here to here. And we need to make this equal, right? And now let's see, because now it's 4 inches. If we change that to 5 inches, then it behaves the way it's supposed to. Half to this side and then half to the other side. Perfect. Now let's go to our front view. And then here, we have to create another plane here for the top. Let's assume this is the bottom one, and then this one's the top. There's no need to create 2 different planes or anything. So let's just select the plane. Right now I'm not selecting the plane, I'm selecting the reference level. So I'm gonna do tab select to select the plane, right click, create similar, and then I'm gonna pick lines. I'm gonna give it, let's say, 4 inches from the top, and then we go to our cut sheet to see exactly what it is, and that distance is 5.5 inches. So dimension, I'm gonna tap select because I don't want to click on the reference level. I want to click on my working plane, which is the one behind it. So click here, outside, and then I'm gonna click on this dimension, and I'm gonna associate it to my exterior height. Type is fine, family parameter is fine, dimension is fine. Now we go to our parameters, and we said it was 5.5. Okay, now let's create our, and then I want my first extrusion to start at the front face of the wall, right? So, and it's gonna be 3/8 of an inch. We already have these planes. We have the large profile of the plate on the wall, and then we have this small profile protruding 3/8 of an inch outside of the edge of the wall. So let's go ahead and do that. So we're gonna pick our front of the wall plane, and that's gonna be our first profile. So I'm gonna go to a front view, and then I'm gonna start a profile. So I'm gonna create my first extrusion, create extrusion, and then I'm gonna select the plane, right? So I have to go here to set work plane, and we said that that was gonna be front of wall, so that's good. I'm gonna click OK, and then what I'm gonna do is just pick lines. So I'm actually gonna pick this one here, this one here, this one here, and this one here. Now we can simply do trim this one to this one, this one to this one, this one to this one, and this one to this one. And this is so small that we could probably just leave it like this, but let's just go ahead and go nice and fillet art. And we know that that's like 1/2 inch. So from here to here, and then we have to say maybe the radius 1/2 inch. There you go. So we can do the same thing here, and then the same thing here, and then the same thing here. That's looking good. But now I realize that if I click finish here, what I did, if I go to my 3D view, is an extrusion, right? So, and that's not really what I wanted. What I want is some kind of loft, or it's actually called a blend here. So yeah, that's not what I want. So I'm gonna undo. And what I'm gonna do is I'm gonna copy this to my clipboard to see if I can reuse it. Who knows? Maybe I can. And then let me just, I want to discard my extrusion, yes. And instead, what I want now is to create that nice blend. So let's go to blend. We need to set our reference plane. Front of wall is okay. And then let's see if I can paste. Yeah, there it is. We saved a little bit of our work, so that's good. All right, so we're done with this one, and now we need to create the other one. So we have the bottom. Now we need to edit the top. So let's go to the top, and then the top is gonna be on which plane? It's gonna be in front of plate. And then that one, let me go ahead and measure in AutoCAD. Actually, I have it here. It's 2 9/16. So that's the total. So pick lines. And then let's give it an offset of, let's say 1 inch for now, this way, and another inch this way. And then, and I realized it would have been nice to have a center plane right here. I think I'm just gonna create it. Let's do things right. But for now, let's just measure it here. So from here to here, we have a certain dimension, and that dimension we're gonna call interior width, and all this is fine. Let's equally constrain them so that it's symmetrical. So from here to here to here, I'm gonna make that equal. So let's see, and then this width, the interior width is 2 9/16 of an inch. So that's 2 9/16 of an inch. That's good. Then we also want to, let me do one like around here. For now, let's give it an offset of 1 inch down here and 1 inch up here. And for now, let's just finish the solid, and then we'll come and tweak it a little bit more. So I'll do TR from here to here, from here to here, from here to here, and from here to here. So let's give it a fillet here, fillet art. What's gonna be our radius? This one's really small, let's say 0.13. And then I click here and here, here and here, here and here, and here and here. And now let's just click OK, and let's see what's going on. Let's go to our 3D view. Ooh, that's definitely too long, right? So let's go to our reference level. Oh, and that's why. So let me see if I can align to this plane. Yeah, it did it. I could lock it, and I'm actually gonna lock this. Now let's take a look at our 3D view. Oh, now it's looking a lot better. So let me give a little shading to this. There you go. That's pretty similar to what we want, right? All right, let's say the aliens calm down and they want to mess around with your YouTube history. What are you gonna do? Can't find my video? No. What you want to do is subscribe to the channel. You hit that bell. That way you get notifications. You know where your video is, and you stick it to the aliens. We're gonna go to our reference level. Oh, there's one more thing. Let's do the DISS diameter. So if I open this up, I can measure it from here. And that's 5/8 of an inch. And it makes sense. We're gonna have to bite the bullet. Let's create a center plane right here. Okay, so tab select, create similar. So we pick plane 2 inches, approach it from the top, and then we're gonna call this DISS because that's where the connection's gonna be, and we want that distance to be half of the exterior height. So let's go ahead and create, and well, we don't really need to create a parameter for that height, right? We can simply just come here and say that from here to here to here, we want this to be equal, and that's right in the middle, so we don't need that, right? And now what? We want now our little extrusion, right, which is 5/8 of an inch. So let's go ahead and go to create, extrusion. We want to create a circle, and just like we've done before, I'm gonna do it like right here, somewhere else, right? And then we click on the circle, we make sure that center mark is visible, and now we align to this reference plane, this one, unlock it, and then to this guy, unlock it. Now we could give a diameter to this and define it as a parameter, but I don't think it's worth it. We know it's just gonna be 5/8 of an inch, but that's the diameter. So it's actually 5/16 of an inch, the radius. And then what's that length? Well, let's go to AutoCAD and measure it. That's 7/8 of an inch. So when we click OK here, we can click on our extrusion, and then our extrusion end can be at 7/8 of an inch. Let's take a look in 3D view. That's looking pretty good. And now we just need the extrusion to the back, the connector. We're like halfway done. So reference level. Let's see, what do we have here? We have 2 inches to the back. And then if we go to AutoCAD, we can see that this dimension is 1 1/4. So let's go ahead and come back here, and we're going to create another extrusion. Let's go to the front view and then create extrusion. We're gonna select the back of the wall plane. We're gonna do a circle just like we did before. Again, click on this thing, center mark visible, then align to this one, unlock it, to this one, unlock it. And now this is interesting. The extrusion, I want it towards the back, right? So I'm gonna do -2 inches so that it goes in the right direction. And I need to give it a certain diameter, right? And we know that that diameter was 1 1/4. So the radius is 0.675. So we click here, 0.675 inches. Enter. And now we finish our extrusion. Let's monitor what we're doing. Very good. And you know, that's not bad. It's simply, this is pretty schematic. You know, we don't want to get too detailed, but we obviously have this going on in here. All I'm doing is modeling this little part here. Now I just want this other plane so that I can have my connector, and then we'll be done. So let's go to the reference level again. Actually, we have the reference plane, I mean. So here, this is our reference plane for that connector, and we properly called it connector. So let's go ahead and create an extrusion, and then we're going to select our plane, and the plane I'm going to select is the middle one, which is the DISS height. I'm going to click OK, and again, I'm doing it on purpose. I'm going to do a little circle here, from here to here. And then we click on it, we make sure that it's visible or center, then align from this one, unlock it, from this one, unlock it. Now we give it a dimension, so the distance from here to here is 1/2 inch. Come back here, and then this is gonna be obviously a 1/4 inch because it's the radius, not the diameter. And now this is looking a little better, right? And then we could give it the actual length of that nipple. It says here it is 7 3/4 inch. So you could do that, you know, give it 7 3/4 inch. Let's see how it looks. So 7.75 inches. And then, okay, that's pretty good. I think I like it. I think I'm gonna keep it like that. Now let's add the connector. So we just come here to create pipe connector. I'm gonna place it right here. Now let's associate this with the pipe diameter. So let's go here to parameters, and let's create a new parameter. It's a family parameter. The discipline is going to be piping. And then the type of parameter is going to be pipe size. We can group this under dimensions. That's fine. And the name of it is going to be pipe diameter. Actually, let's call it pipe size. Okay. And now that pipe size is going to be 1/2 inch. Okay. But we haven't associated this to that, right? So we click here, diameter, click here, and then we associate to pipe size. Okay. And now that's looking pretty good. Now we need to click on our connector and we need to see what type of connector it is. As far as flow configuration, this one's going to be preset because I'm going to specify what's going on in there. So preset the flow direction. I'm going to do first the positive pressure gas. So like compressed air, oxygen, nitrogen is coming in to our family. So that's the flow direction, is in. And then the system classification is going to be hydronic supply, because Revit thinks that it's GPM, but it's actually CFM or number of outlets or whatever. Then as far as flow, let's bring in a couple of AJS parameters here. And if you don't have those, you can get those at the website. So you can actually just scan the QR code that you see on the screen. So let's go ahead and bring in our parameters. New parameter. It's going to be a share parameter. So share parameters, we go to plumbing, and then we want MedGas Outlet flow in CFM. And we want to group this parameter. We can keep it under mechanical. I think it by default, it takes it to mechanical, even if you put it under plumbing. So here it is, plumbing. That's my parameter. And let's say this is 1 CFM, just for fun. Then I'm going to click OK. And now I'm going to have my connector read my flow to be that parameter. And there it is, 1 GPM. That's really good. And this one's going to be our positive pressure one. And then for the negative pressure, you do the opposite. It's hydronic return and then it's out. Okay? And if you're enjoying this content, there are many ways you can support it. You can like or leave a nice comment down there. It really helps me out. You can subscribe to the channel so you don't miss any new videos. You can join our Patreon community in the link you see on the screen, which is also in the description. You can spread the word around, share it with your coworkers and in social media. And if you know any MEP firms that need help with BIM migration or any other topics, you can let them know so that I can help them. All right, so let's give this a shot. Let's drop a positive pressure outlet. Let's say 3 feet above finished floor. There we go. And then let's drop one for vacuum. Also 3 feet. And just for fun, let's copy this one over. And let's say this one, let's try to tag them first, TG. Actually, I don't have the parameter in this family yet, so let's go ahead and add it. New parameter, share parameter. Let's select from plumbing, the AJS share parameters. And this one's gonna be AJS MedGas Outlet ID. MedGas Outlet ID. This is gonna be a type parameter. We can group it under plumbing so we can find it a little bit easier. And this, since this one's the positive pressure, I'm gonna go ahead and add 3. One of them is gonna be oxygen, and that one's gonna have the outlet ID is OX by default. Let's create another one, medical air. That one's gonna have MA. That one's gonna have CO2. Let's add a nitrogen. That's N. And a nitrous oxide. That's NO. And I think that's it. Let me see, CO2, medical air, nitrogen, nitrous oxide, and oxygen. Yeah, so let's see like that. Okay, let's save. Load into project. And then this one, let's make it oxygen. This one, let's make it medical air. Let's make sure it's taking it. Yep. And then this one, remember this one's the vacuum. So let's go ahead and edit the family because we don't have the tag parameter. New parameter, share parameter, select from plumbing, AJS, MedGas Outlet ID. Type parameter, group it under plumbing. And then this one's gonna have two types. One of them is gonna be medical vacuum. That's gonna be MV. And the other one's gonna be WAGD, waste and aesthetic gas disposal. Save. Load into project. Now we tag. By default, it has the last one I created, so let's change it to vacuum. And now let's see, if I take this 1/2 inch up, let's say to 8 feet, take it this way. We want to make this oxygen. We're going to do the same thing with medical air. Let's say 8 feet. And then finally vacuum. Let's do also. Let's close the two families. Take this a little bit higher, say 8.6 or 8.4. And then this one is the oxygen. Oxygen, medical air, and medical vacuum. Let's see how much is coming out. 1, 1, 1. Let's change the values. And actually this value should not be a type parameter, it should be an instance parameter. Yeah, I think I'm gonna make it an instance parameter. That way you can modify the flow just like if it was a diffuser, right? So go ahead and change this one first. So this flow parameter right here, we need to edit it, and it's going to be instance. And I'm going to get rid of this type so it's a little bit cleaner. Okay, save, load into project, overwrite. Now I can take this guy and I'm going to make this, let's say, 2 CFM. I'm going to edit this one. And again, this is going to be an instance parameter. NO, CO2, medical air, medical. I'm going to take this generic one. I'm going to delete it so I only have specific gases. And let's keep it as medical air by default. Save. Load into project. Overwrite. And then this one here, I'm gonna say this is 3. And I'm gonna say this is 4, just for testing purposes. So this pipe here is reading 2, so that's good. This one here is reading 3, so that's good. Get rid of these tags here. And then this one here is reading 4. So let's see. This one reading 4. This one reading 3. And this one reading 2. Perfect.